Good morning friends. Welcome to our class. Today we are going to discuss about 18 electron count method. In our previous video we have discussed the basic rules required to understand this 18 electron count method like heptacity and minimum basics of 18 electron rule. Okay, let us start today's class. See, 18 electron count method. See, it is of two types, neutral atom method and ionic or oxidation state method. OS means here oxidation state method. So electron count can be done by two methods, neutral atom method and ionic oxidation means ionic or oxidation state method. Okay, see, in my previous video only I have given this. Okay, let's see once more because this is actually the most important thing. See, valency shell electrons or total valency electrons. So to find the total valency electrons we had to use this. See, valency electrons of metal plus electron contribution of ligand plus or minus charge on metal, means depending upon the charge we may sum or subtract that particular charge, like that. So the sum of these three must be equal to 18, then only that particular complex is said to be stable. Okay, see, this means we should know valency electrons for this. This is actually the important thing for us. Okay, see, we know that this is a 3D series, 4D series, 5D series. See, in the 3D series, and these are the valency electrons. See, first I'll read out once. Okay, these are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Means in question they may give us chromium, means we should know the valency electrons. So in chromium the valency electrons are 6, like that. Okay, if they give nickel means the valency electrons present in the nickel is 10, like that. Yeah, next 4D series. 4D series means the elements present in 4D series are yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, cadmium. Same here also, if they give molybdenum means just we should know the valency electrons present in molybdenum, that is 6. Yeah, like that, just we had to look at the valency electrons so that we should remember the elements present in all this, like 3D series, 4D series, 5D series and so on. Let me read this also. The elements present in the 5D series are lanthanum, hafnium, tantalum, wolfram, rhenium, osmium, iridium, platinum, gold, mercury. Okay, these are actually the important things which we should remember. Next, see, we have to remember this also because these are very important to solve, means to find the 18 electron, like that. See, this is means whatever may be the question, if you find Cp means, so electron contribution by this Cp is 5 electrons. See, Cp, P means penta, cyclopenta, like that. So here the electron contribution by this is 5 electrons. Next, halogens. So electron contribution by the halogen is 1 electron. See, this is actually the phosphorus containing compound. Okay, so this phosphines means electron contribution by this phosphines is 2 electrons. Next, we know this is carbonyl and the electron contribution by the single carbonyl is 2 electrons. And alkyl, electron contribution by the alkyl is 1 electron. So we should remember this. Once again, Cp means 5 electrons, halogens 1 electron, phosphine groups means 2 electrons, carbonyl 2 electrons, alkyl 1 electron. Okay, let us start. See, in this video I'll explain both the methods like neutral atom method and oxidation state method, but mostly if we follow neutral atom method then it will be easy for us. Okay, let me explain both. First let us look at neutral atom method. See, this is actually the complex. Yeah, in neutral atom method, see, it's really very simple. See, this is actually the manganese. So first we should know the electrons, valency electrons present in the manganese. So let's look at here. Yeah, this is the manganese and the valency electrons present in the manganese is 7. So for manganese, here we have mentioned 7 electrons. Methyl, already I said that electron contribution by the alkyl group is 1 electron, and here they have given carbonyl. So here we discussed 1 carbonyl means 2 electrons, but here they have given the 5 carbonyls, so 5 into 2, 10 electrons. So if we count all this, we will get 18 electrons. So we can say that this complex is stable. So here we have followed neutral atom method. Yeah, next let's see this oxidation state method. See, in this method we should know the charge possessed by this. Okay, first, yeah, we know that the charge on the alkyl group is -1. Okay, alkyl group, we already know that means in alkyl group the electron donating tendency is 1 electron. Okay, see, so here we have to find for manganese. So now we are finding the charge for manganese. Okay, see, alkyl means -1, we know this, and we have to find manganese. So here we assume it as X plus carbonyl. We know that CO is a neutral, so it's means it has no charge, so 0, 5 into 0, so -1 plus X, X is equal to +1. So here the manganese exists in +1 oxidation state. Okay, let us start this. Yeah, just now we found that here the manganese exists in +1, so manganese +1 first means of course it is also mostly similar to this method only. Here also we should know the number of valence electrons. Okay, see, manganese, see, look at here, manganese, the valence electrons present in the manganese is 7. Okay, see, 7, but here the manganese exists in +1, so that from 7 we had to subtract 1, so that here we will get 6 electrons. Similarly, methyl, already we discussed alkyl group means 1 electron contribution. Okay, and here its charge is -1, that's why here adding 1, so here we get 2 electrons. Similarly, here they have given 5 carbonyls. 1 carbonyl means 2 electrons, so here they have given 5 carbonyl groups, that means 10 electrons, so 18 electrons. So see, that means we can say that the given complex is stable. Okay, let us see one more example. Yeah, okay, this is ferrocene. Ferrocene is a sandwiched complex, already we know this. Okay, let us see both the methods for this ferrocene also. Okay, see, here this is the iron. Yeah, we know that the valence electrons present in the iron is 8. Yeah, let us look at here. See, this is the iron and the valence electrons present in the iron is 8. Okay, so iron valence electrons are 8, and already I said that Cp, wherever you find Cp means 1 Cp contribution is 5 electrons. Here they have given 2 Cp, so 5 into 2, 10 electrons, so total 18 electrons. So we can say that this is stable. Okay, next, this is oxidation state or ionic method. Yeah, see, here iron means Fe exists in +2 state. We know that valence electrons present in the iron are 8. As here we have +2 means here we have to subtract 2. So here we will get 6 electrons. And similarly, see, this is Cp. For 1 Cp I told 5 electrons. Here they have given 2 Cp. That means 10 electrons. See, for 1 Cp they have mentioned 1 minus charge. Here we have 2 Cp, no? So that here we will have -2 charge. So 10 plus 2, 12 electrons. Totally here we will get 18 electrons. So number of electron count in both neutral method and oxidation method are same. So this is also a stable. Okay, next. Yeah, let us see some of the questions on 18 electron rule. See, first question. Which complex follows 18 electron rule? And these are the 4 options here. Okay, let us see all these things. Okay, already I said that Cp means here its electron contribution is 5. Iron, the valence electrons present in the iron is 8. Already we discussed it, right? Yeah, next, carbonyl. 1 carbonyl means 2 electrons. Here they have given 2 carbonyls, that means 4 electrons. 5 plus 8 plus 4 means here we will get 17 electrons. Okay, next, Cp, already I said Cp means 5 electrons. Molybdenum, so we know that the valence electrons present in the molybdenum is 6. Carbonyl, 1 carbonyl means 2 electrons. 3 carbonyls means 3 into 2 6 electrons. So here also we will get same 17 electrons. Next see Cp, 1 Cp means 5 electrons. Here they have mentioned 2 Cp means 5 2s are 10. Okay. Next this is a cobalt. The valence electrons present in the cobalt is 9. So 10 plus 9 19 electrons. Okay. Next already I said for Cp2 we will take 10 electrons. Here also Cp2 is there. So here also we have to take 10 electrons. And ruthenium. Okay. Yeah, ruthenium. So we should know the number of, means it is very important to remember all the elements present in 3D series, 4D series and 5D series. Then only it is easy for us to solve this. See, in the question they have asked ruthenium, right? Yeah, this is the ruthenium. So the number of valency electrons present in the ruthenium is 8. Okay. See, so 10 ruthenium is 8 electrons. So 10 plus 8 18 electrons. Okay. What is the question? Which complex follows 18 electron rule? See, among the 4 only this one follows 18 electron rule. So our answer is 4. Okay. Next. See, let's see next question. The neutral complex which follows 18 electron rule. Okay. Let us see. See, yeah, I think if you have watched my previous video, then you will get idea about this. This is heptacity. Okay. If you want to know about the heptacity, watch my previous video. Okay. This is eta. Eta means here the power 5. 5 indicates its heptacity. Okay. So eta 5 means here we had to take 5. Next iron. Iron means its valency electrons are 8. And carbonyl 2 means for one carbonyl 2 electrons. Here they have given 2 carbonyls. So 2 plus 2 4. So 5 plus 8 plus 4 means 17 electrons. Next. See here also eta 5 means heptacity is 5. Okay. Next molybdenum. Valency electrons present in the molybdenum are 6. Next carbonyls 3 means 3 2s are 6. So totally here also we will get 17 electrons. Next here also eta 5 means heptacity 5, but here they have mentioned 2 means 5 into 2, so 10. And cobalt, so the valency electrons present in the cobalt are 9, so 10 plus 9 19 electrons. Next see here also the heptacity is 5. Okay. Next rhenium, so the valency electrons present in the rhenium are 7. If you have doubt, please go through that 3D, 4D and 5D series, means the elements present in those series. Then we will get idea about the valency electrons. Okay. Next here the heptacity is 6. So 5 plus 7 plus 6 18 electrons. What's the question? The neutral complex which follows 18 electron rule. So here our answer is 4, friends. Okay. Next. Yeah. Let us see our third question. Which of the following means which of this following follows 18 electron rule? Okay, let us see. Sorry. Yeah. Let us see this first. Already I have mentioned in my previous video. If they means actually this is the metal. Okay. This metal is connected to this circle. So just here we have to count the number of atoms present in this. So 1, 2, 3, 4, 5. So here the heptacity is 5. Okay. If you have watched my previous video, then you will easily understand this. Okay. So here the heptacity is 5. Next copper. So the valency electrons present in the copper is 11. We know that based on the series we can tell. Okay. Next 1 carbonyl means 2 electrons. So here we will get 18 electrons. Okay. Next. See, let us look at this. Here also same, friends, this chromium is attached to this circle. Just count the number of atoms. 1, 2, 3, 4, 5. So here the heptacity is 5. Next chromium. So valency electrons present in the chromium is 6. We know this. Yeah. Next carbonyl 3 means 3 2s are 6. So here we will get 17 electrons. Next. So here also the same thing. Manganese is attached to this circle. So that here we had to count the number of atoms. So 1, 2, 3, 4, 5. So here the heptacity is 5. Manganese. So valency electrons present in the manganese is 7. Next carbonyl 2 times. So 4. So if we count this, we will get 16 electrons. Next. Fourth option. Here also the heptacity is 5, friends. Next here this is a vanadium. Valency electrons present in the vanadium is 5. Here they have mentioned carbonyls 4 times, means 4 to the 8. So 18 electrons. What is the question? Which of the following follows 18 electron rule? So both A and D follows 18 electron rule. Okay, I think it is clear. Yeah. Next, let us see. See, based on the 18 electron rule, they may frame the question like this also. See, here the question is, choose the isoelectronic pair among the following. Okay. Yeah, here also they have given the 4 options. Let us see all the options. Okay, see, we have to choose the isoelectronic pair among this. See, first one. Here also same thing. Vanadium means the valency electrons present in the vanadium are 5. Carbonyl 6 means 6 to the 12. So here we will get 17 electrons. Okay. Next B. See, copper. The valency electrons present in the copper are 11. Eta 5 means heptacity is 5. 1 carbonyl means 2 electrons. So we will get 18 electrons. Okay. Next. See, cobalt. The valency electrons present in the cobalt are 9. 1 carbonyl means 2 electrons. So here they have given 4. So that 4 into 2, 8. And here they have given minus charge. So that here we had to add 1. So plus 1. So 18 electrons. Next. See, this is actually the viscose complex, friends. Okay. Viscose complex. This is viscose complex. This is a bis triphenylphosphine iridium chlorocarbonyl, I think. Yeah, this is viscose complex. Yeah, let us see this. Iridium means the valency electrons present in this is 9. Chlorine, already I said that halogens exhibit 1, means their electron contribution is 1, means the valency electron is 1. Next, carbonyl. Single carbonyl means 2 electrons. For phosphines, 2 electrons. Here they have given 2. So 2 to the 4. Here 16. We may get doubt that if the complexes follow 18 electron rule, then only they are said to be stable. But here this viscose complex has only a 16 electrons. Then how can it will be stable like that, we may think. Already I discussed in my previous video that square planar complexes are said to be stable even they possess 16 electrons, friends. That we should remember. Okay. What they asked in the question, isoelectronic pair means same number of electrons. See, here 17, 18, 18, 16. So B and C are the isoelectronic pair, friends. Okay, next. The stable cyclopentadienyl complex of beryllium is. First we should see at this beryllium. Beryllium is it is a main group element. Okay, this is not a transition element, right? So main group elements are said to be stable if they follow octet. Okay, that we should remember. Yeah, let us see at these 4 options. This is beryllium. The number of electrons means the valency electrons of beryllium are 2. Eta 5 means we know that here the heptacity is 5 and here they have given 2. So 5 to the 10. So 12 electrons. Next, beryllium. Beryllium means we know valency electrons in beryllium is 2. Eta 2 means heptacity 2. Here eta 3 means heptacity 3. So 2 plus 2 plus 3, 7 electrons. Next, beryllium means its contribution is 2 electrons, means valency electrons. See here heptacity is 1. So 1. Next, here the heptacity is 3. So 3. So 2 plus 1 plus 3, 6. Next, beryllium means its valency electrons are 2. Here the heptacity is 1. Eta 1 means heptacity 1. Next, eta 5 means here the heptacity is 5. So here 2 plus 1 plus 5 means 8 electrons. Okay, what they asked? The stable cyclopentadienyl complex of beryllium. I said that main group elements are said to be stable if they follow the octet rule. So let us check the options in which we got 8 electrons. So indeed here we got 8 electrons. So this is said to be stable. Okay, see main group elements if they follow octet rule then they are said to be stable. Next. Yeah, let us see the last question of today's class, friends. Yeah, they have given a complex and they said that this follows 18 electron rules. Then M, X and Z means they are asking that what may be the element, means what is the metal and what is the number. Here we have to insert like that, means here they have given 4 options, just we have to substitute and check, friends. That's it. So wherever we get 18 electrons means that particular complex is said to be stable and it will follow the 18 electron and that will be our answer, friends. See here these are the options they have given. Okay, let's substitute. See, in place of M we had to insert titanium. See, titanium. And here in place of X, 6. So in place of X I have inserted 6. Next Z place we have to keep 1. So 1 minus C. So yeah, the same thing friends here also. In place of M, vanadium. In place of X, 6. In place of Z, 1. Like that we have to substitute in all these cases. Okay, let us see the electron count. The valency electrons present in the titanium is 4. We know that 1 carbonyl means 2 electrons, 6 carbonyls means 12 electrons. 1 minus means here we had to add 1 electron, so plus 1. So here we will get 17 electrons. Next, valency electrons present in vanadium is 5. Okay, 6 carbonyls means 6 into 2, 12. 1 minus means here we had to add 1 electron, so 18 electrons. Similarly, this is cobalt. So the valency electrons present in the cobalt is 9. So carbonyls are 4. So 4 2s are 8. Next, minus 2 means here we had to add 2. That is 19 electrons. Next, molybdenum. So the valency electrons present in the molybdenum are 6. Here the carbonyl group. So 5 2s are 10. Yeah, here they have given minus 1. So we had to add plus 1. So here we will get 17 electrons. See, in the means what they asked, which complex follows 18 electron rule. See, here this is the complex which follows 18 electron rule. So here our answer is B friends. Okay, this complex follows 18 electron rule. I hope you understood friends. If you have any doubts you can ask in the comment box friends. Thank you.